This lesson we'll be looking at parallel and perpendicular lines. This is lesson 6.6 in our text. So non-vertical lines are parallel if they have the same slope. Any two vertical lines are parallel. Okay, so vertical lines, you think about vertical, they're straight up and down. So their slope is undefined. So if you have two undefined slopes, they will be parallel as well as lines that have the same slope. Perpendicular lines are two lines in which their slopes multiplied together give you -1. So a vertical and a horizontal line are also perpendicular to one another. Those are like our special cases. So parallel lines are lines that will never intersect, and perpendicular lines are lines that form right angles. The product of a number and its negative reciprocal is -1. So think about our inverse, or the reciprocal. So if you multiply two reciprocals together, you should get 1. And obviously negative reciprocals, you'll get -1. So we are asked to write a parallel line that goes through this point right here, and it's parallel to this. So the first thing you need to do is identify the slope. What is the slope of our line? And so our slope is going to be 5/2 or 2.5. We're just going to leave it 5/2. So if you think about that, if the slope of that line is 5/2, then that means the parallel slope, and I'll use those two lines to mean parallel. So the parallel slope is also going to be 5/2. Okay, so now we have a slope and we have a point, right? We have a point right here. So we can use our point slope form or formula and say y minus the y value, which is 3, equals our slope, which is 5/2, times the quantity x minus that -2. Okay, so we're gonna have to watch our double negatives there. So if we start to simplify this expression, we have that 5/2 x, and then if we take 2 times 5/2, guess what that gives us? That gives us 5. So this is actually going to work out beautifully for us. And then we're going to add 3 to both sides so that we have only the y left on the left side. And we have 5/2 x plus 8. There we go. We just wrote a parallel line that is parallel to this first equation up here and goes through that point. And you can also check by plugging in that -2 there, multiplying that gives us -5. -5 plus 8 is 3, which is the y value. So there's just a quick check as well. Here we're looking at perpendicular lines, and so the first thing you need to look at is that the line in the graph represents streets in front of a house. The sidewalk from the front door is perpendicular to the street. So there's the sidewalk and there's the street. So write an equation representing the sidewalk. Well, so the first thing we want to do is, since we could find the slope and the y-intercept of that sidewalk, but we have some nice points here in our street. So if you look at that right there and that point right there, or that point right there, are great intersecting points that we can see our slope of our street is going to be -2/3. Do you see that? So the slope of our street is going to be -2/3. So we go down 2 over 3. And you can see that again, down 2 over 3. So the slope of our street is -2/3. That means the sidewalk, since we're told it's perpendicular, the perpendicular slope is going to be the negative reciprocal. Since it's a negative number, it's actually going to become positive, and we take the reciprocal of that. So the perpendicular slope is going to be 3/2. And then you're asked to write an equation of the sidewalk. Now that we know our slope, we can see our y-intercept there is, oh, I just erased, I believe it's -3. 1, 2, 3. Yes, our y-intercept there. So our point, which is 0, -3, which is also our y-intercept. So we can just plug in our slope for the m, and then our y-intercept is -3. And so that is the equation then of the sidewalk.